We've now covered the steps in hypothesis testing in general and specifically for the z-test for one population proportion. Now we want to discuss a few issues regarding hypothesis testing, which are the effect of sample size on hypothesis testing, the difference between statistical significance and practical importance, and how hypothesis testing and confidence intervals are related. We've already seen the effect that the sample size has on inference when we discussed point and interval estimation for the population mean mu and the population proportion p. Intuitively, larger sample sizes give us more information about the true nature of the population. We can therefore expect the sample mean and sample proportion obtained from a larger sample to be closer to the population mean and population proportion respectively. As a result, for the same level of confidence, we can report a smaller margin of error and get a narrower confidence interval. In hypothesis testing, larger sample sizes have a similar effect. We've also discussed that the power of our test increases when the sample size increases, all else remaining the same. This means we have a better chance to detect the difference between the true value and the null value for larger samples. The following two examples will illustrate that a larger sample size provides more convincing evidence the test has greater power, and how the evidence manifests itself in hypothesis testing. Let's go back to our example 2, marijuana use at a certain liberal arts college. Here we took a sample of 100 students and found that 19% used marijuana. The result of this test was that we failed to reject the null hypothesis. The data from this sample did not provide enough evidence that the proportion of students at the college who use marijuana is higher than the national figure of 15.7%. Now let's increase the sample size. Suppose that in a simple random sample of 400 students from the college, 76 admitted to marijuana use. Do the data provide enough evidence to conclude that the proportion of marijuana users among the students in the college, P, is higher than the national proportion, which is 0.157. Now we have a larger sample, but the same sample proportion of 0.19. When we go through the process, the p-value is now 0.035, and we reject the null hypothesis. Check the results for yourself for extra practice. So the data from this sample do indeed provide enough evidence that the proportion of students at the college who use marijuana is higher than the national figure of 15.7%. Results that are based on a larger sample carry more weight. They have greater power. In our sample of size 100, we failed to reject the null hypothesis, but this only means that the particular study didn't yield sufficient evidence to reject the null. It might be that the sample size was simply too small to detect a statistically significant difference. However, with the larger sample, we saw that when the sample proportion of 0.19 is obtained from a sample of size 400, it carries much more weight, and in particular provides enough evidence that the proportion of marijuana users in the college is higher than 0.157. In this case, the sample size of 400 was large enough to detect a statistically significant difference. Let's look a little at interpreting non-significant results. Suppose that only 40% of the U.S. public supported the general direction of the previous U.S. administration's policies. To gauge whether the nationwide proportion P of support for the current administration is higher than 40%, a major polling organization conducts a random poll to test the hypotheses HO P equals 0.4 versus HA P is greater than 0.4. The results are reported to be not statistically significant with a p-value of 0.214. Now let's look at a few statements and discuss some invalid conclusions to avoid. There are correct ways to think about results which are not significant, and there are a few common misperceptions. It is valid to say that the results do not reject the null hypothesis. It is not valid to say the results provide enough evidence to accept the null hypothesis. It is not valid to say that results indicate that the nationwide proportion P of support for the current administration is equal to 40%. It is valid to say results indicate that the nationwide proportion P of support for the current administration might be greater than 40%, but the sample size in the study might have been too small to detect the difference that exists. Remember that in hypothesis testing, failing to reject the null hypothesis does not allow us to say that the null hypothesis is true, only that we do not have enough evidence to reject it.